Hey everyone, here's a video on rewriting quadratic functions. This is a worksheet that you can get in class or print off the website if it's working right now, and let's work through this. It may be a little bit of a lengthy video, so have your notes ready, and here we go. Okay, so write f of x in vertex form and identify the vertex. So for f of x equals x squared plus 8x minus 10. Your book would show this doing it a different way, but I think we should go a little bit simpler route and just find the vertex and use that to write the equation. So remember the vertex, the x value for the vertex is x equals negative b over 2a. So we'll get negative 8 over 2 times a, which is 1. So negative 8 divided by 2 is negative 4. And then remember to get the y value, we plug that back into our equation. So negative 4 squared plus 8x. 8x, x is negative 4, minus 10. Well, that equals negative 26. So the vertex is at negative 4, negative 26. So if we have the function f of x, we know that it's set up, remember it's f of x equals a times x minus h squared plus k, where hk is the vertex. Well, here a is equal to 1, so we'll leave that alone. Then we'll have x minus a negative 4, so x plus 4 squared, and then plus k, which is negative 26. And that's our function right there. By the way, if you looked in your book, they would show you how to do it using completing the square, but there's a couple of things in there that can be a little bit tricky. That's why I'm just suggesting to use this instead, but you're more than welcome to check it out in the book. So let's jump down to if a were not equal to 1. Number 2, I would like for you to work on your own, but number 3, let's look at that, where a is 2. It's not equal to 1. But we can do the same thing. So let's look for the vertex. So we have x equals negative b over 2a. Okay, well, negative of negative 8 is positive 8 over 2 times a, which is 2. So we have 8 divided by 4, which is 2. And then we get y. We have to plug that back in. So 2 times 2 squared minus 8 times 2 plus 3, and that gives us negative 5. So it's okay that a is not equal to 1. We'll just bring the a down like we did before, so equal to a, and ax squared plus bx plus c is the same thing as the a in vertex form. So we'll bring the a down, which is 2, and then we have x minus h, so we have x minus 2 squared, and then plus k, which is negative 5. And that's our function. Not so bad, right? Okay, so let's look at an example. Doing the whole process, including switching from vertex form and from standard to vertex form. So again, we have, let's use a different color. If we have 2x squared minus 4x minus 6, and we want to put it into vertex form, we'll have x equals negative b over 2a. So we will have negative of negative 4, it's positive 4 over 2 times a, which is 2. So 4 divided by 4 is 1. And then to get the y value, we just plug that back in. So we have 2 times 1 squared minus 4 times 1 minus 6. And that equals negative 8. So we could just fill in the vertex right now. We know that it's 1, negative 8. But for this equation, g of x, if we want to write it in vertex form, you bring down the a like it was before, so 2, open parentheses, x minus our x value, the vertex, so x minus 1 squared, and then plus the y value, so it's negative 8. So there's the vertex form of the equation. Does this open up or down? Well, a is positive, the number in the front is positive, so therefore it opens up. The equation for the axis of symmetry, that's x equals negative b over 2a, or just x equals the x value of the vertex, which we already found out, which is 1. Does this graph have a maximum or a minimum value? Because it opens up, it has a minimum value, and that value matches the y value of our vertex, which is negative 8. So the y-intercept here, remember, that's just where it crosses the y-axis, so where x is equal to 0. But because we're given it in standard form, it's really easy to figure out what it is. It's just c for ax squared plus bx plus c. So we have 0, -6. And look at the x-intercepts from the graph. The domain will always be all real numbers, and then range. Here, because it opens up, we'll have y is greater than or equal to, and then our minimum value is -8. So our range will be y is greater than or equal to -8. So if we have the vertex 1, -8, and we can still use the 1, 3, 5 thing. If you don't know what I'm talking about, go back a couple of videos and watch that one. 1, 3, 5 gets multiplied by a, which is 2. So we have 2, 6, and 10. So starting at our vertex, we'll go just out 1 up 2. Then we'll go out 1 up 1, 2, 3, 4, 5, 6. There's our x-intercepts. And then out 1 up 10. Generally, we just like at least 5 points, but I like to put on the graph as many as will fit. A little shaky. Okay. So there's our graph. The x-intercepts, where y equals 0, they cross at nice pretty points. So we have -1, 0, and 1, 2, 3, 3, 0. If it did not cross at a pretty place on the graph, then make sure you can just set the y equal to 0, the function equal to 0, and solve for x, and that will give you the same thing. So how does this compare to our parent function? Well, it's narrower. It's opening the same direction as our parent function, but it is also moved left and down so that the vertex is at 1, -8. Okay, let's look at a couple of application problems. Find the maximum area of the rectangle below. So we have -2x and we have x plus 20 as the length and width of this rectangle. We know that area is length times width. Old news, right? Area is length times width. So here, the length is -2x and the width is x plus 20. So to get the area, we just multiply that out. We'll get -2x squared minus 40x. Well, it's asking for the maximum area. And if you look at our function, area, we could replace that with y equals or f of x equals. So if we're looking for the maximum area, we're looking for the maximum value, which remember is just the y value at the vertex. So if we want to find the vertex, that's x equals, to get the y we have to get the x first. So we'll have -b over 2a. So negative of -40 is positive 40 over 2 times a, which is -2. So 40 divided by -4 is -10. So that's just an x value. But we want the y value for the vertex, in other words, the a. So we have y equals, we're just going to plug that back in. So -2 times -10 squared minus 40 times -10. And we get 200. So we found the y value at the vertex, so the max area is 200. Okay, so what would be a reasonable range for this problem? Whenever it's asking reasonable range, this is saying in this situation we want to make sure that it does not go negative. We don't want area to be 0, we don't want the area to be negative, so the reasonable range for this problem, well, if we know that the maximum area is 200, so it has to be less than or equal to 200, but we also don't want it to be 0 because then the rectangle disappears, so it has to be greater than 0. So you could write it in this form, or remember you could also do it in interval notation, just like that. Either of those is fine. Okay, now let's look at number 7. Erin and her friends launch a rocket from ground level vertically into the air with an initial velocity of 80 feet per second. The height of the rocket, h of t, after t seconds is given by h of t minus 16t squared plus 80. How long will the rocket stay in the air? And then what would be the reasonable domain for this problem? So whenever it's asking stays and how long will it stay in the air, that's asking basically before it hits the ground. In other words, when h of t or y equals 0. In other words, the x-intercepts. So if we have negative 16t squared plus 80t, that's our function. And we're trying to figure out when will the rocket hit the ground? When will it have a height of 0? Or when will y be equal to 0? So if we set this function equal to 0 and solve for t, so here we have a GCF of negative 16t. So when we take out the negative 16t, we have t minus 5. Since these factors are multiplied to 0, we'll set each of them equal to 0. So here we get t equals 0, and here we get t equals 5. We're not interested in t equals 0 because that is not when it hit the ground, that was the launch at time 0. But this is whenever it hits the ground, whenever the second time it has a height of 0. It had a height of 0 on leaving the ground and a height of 0 when it hits the ground. So that's the landing that we're looking for. So how long will the rocket stay in the air? It's in the air for 5 seconds. It also asks, what would a reasonable domain be for this problem? Remember, we want to keep this in real life. In other words, where that rocket is still above ground. In other words, where that time value or the x value is positive. We want to stay in the first quadrant. So we know that the rocket, remember our time is our x value. So our domain will deal with the time. So if you can see that the rocket left the ground at time 0. So it existed at time 0. And it landed at a time value of 5. So we can include 0 and 5, but we cannot go outside of that boundary because if we go negative, we would have negative time, and we're not time traveling here. And if we go positive, then the rocket would be going underground, and that's not happening either. So we are going to leave the domain, the reasonable domain for this problem, to be 0 to 5, including 0 and 5. And then finally, number 8, find the dimensions and maximum area of a rectangle if its perimeter is 24 inches. Okay, so I'm going to draw the rectangle. It's always good to have a visual. So if we have length here and width here, it tells us the perimeter is 24 inches. So 24 is equal to, the formula for perimeter is 2 times length plus width. And we also know that the area of a rectangle, just in general, is length times width. So what we need here is a quadratic. And we can only get a quadratic when we're multiplying, like an x times an x will get us an x squared, and that'd be a quadratic. So let's work with this first one that we have more information in. Let's solve for one of the variables. I'm going to solve for, it doesn't matter, I'm going to pick w. So first I'm going to divide both sides by 2. So I get 12 equals length plus width. So if I solve for w, I get w equals, if I subtract the L, plus 12. So the width will be negative L plus 12. So if I plug w in, this negative L plus 12, in for w, if I substitute that in, I will get the area is equal to L times negative L plus 12, which is equal to negative L squared plus 12L. So there's our area. We're looking for the maximum area. So again, we want to look at that vertex. That means look at the vertex of this quadratic right here. So to find the vertex, the maximum area will be the y value, and the x value here for this quadratic will represent the length. So L will equal negative b over 2a. So I'll have negative 12 over 2 times a, which is negative 1. So negative 12 divided by negative 2 is 6. So to get the area, in other words, the y value for this vertex that has an x value of 6, remember we plugged that in, so we'll get a equals negative 6 squared, then made negative, plus 12 times 6, and we get 36. So we know the max area now. Yay. Okay, so our max area is 36. And we know that occurs when the length is 6. So length is 6. So to figure out what is the width, well, area is length times width, so if the length is 6, then the width must be 6 as well. So the dimensions are, it's a 6 by 6, and this rectangle actually turned out to be a square, but that's okay because a square is a rectangle, and it will have a maximum area of 36 if the perimeter is given as 24, which here 6 times 4 is 24. It all works out. We've done it. Great job. Hope that made sense and you took notes, and you will have an additional assignment to work on in class, and I'll see you later. Bye.